Thank you very much for following my YouTube channel. Today I'm coming up with another video on atomic structure, and my mission is to allow or to assist students out there in both the old and new curriculum to understand chemistry and come up with the best they can present such that we can realize great scientists in our nation. Before I start off with atomic structure, I would like to remind you to subscribe, like my videos, and comment about them. Try to share the link with other people such that they can also have a change in whatever they are trying to be displayed to. Today, looking at an atom, I would like to say that an atom should be a small, is the smallest indivisible particle of an element that can take part in a chemical reaction. When you look at this atom, we are going to say that an atom is electrically neutral, i.e. Positively charged particles are equal to the negatively charged particles. So you can also define an atom as alternative definition. You can also say an atom is the smallest indivisible electrically neutral particle of an element that can take part in a chemical reaction. So that is another alternative definition you can use to come up with the definition of an atom. Structure of an atom. If you want to understand the real structure of an atom, you're going to find out that it is made up of two main parts, has two main parts, i.e. Roman 1, the nucleus, and Roman 2, energy levels. Energy levels, sometimes we are going to call them the shells. Then has three fundamental particles. And these fundamental particles include 1, protons, These ones are positively charged and found in the nucleus. Number 2 are neutrons, which are negatively charged. No charged or no charge. Somebody else will say they are neutral. These ones are found in the nucleus. Number 3 are electrons, which are negatively charged. They are negatively charged and found on energy levels. All these particles can be denoted by particular letters. In case you have protons, protons are going to be denoted with capital P. Neutrons will be denoted with capital N, and electrons are going to be denoted with a small e. So briefly, that is the general introduction of an atom. And if we are to represent what we've drawn here or what we've described here in terms of, if we are to represent it in terms of the drawing, to come up with the drawing of the structure of an atom, we can put a clear drawing to represent what we have written on the structure of an atom. So when your drawing put into place or put into consideration the particular things you have talked about, number 1, we said the 2 main parts of an atom include a nucleus. So we shall begin by drawing a nucleus, which has protons represented by capital P and neutrons represented by capital N. Around the nucleus, we have shells, and the number of shells surrounding the nucleus depend on the atomic number of an atom, which we are going to see next. So if I'm to put electrons, electrons will be placed at least 2 on the first shell that comes just after the nucleus, and a maximum of 8 on the next shell that comes after the first shell. So if we are to label very well our drawing here, this and that are called energy levels. This and that are standing in for electrons. This is a nucleus. Within a nucleus, N is representing neutrons, and P is representing protons. So simply, that is how we can represent the structure of an atom. And when we come up with the structure of an atom, this one opens a door for us to see that different items on an atom can be clearly explained. For example, the second subheading we are going to meet is how to write a full symbol of an atom. If you were to write a full symbol of an atom, you need the symbol of that element. For example, I'm using Z to be the symbol of the atom I want to represent, just Z. You will find a letter below Z, which I'm calling X, and a letter above Z, which I'm calling Y. So each letter represents something which is very crucial in the understanding of an atom. The letter below, which we call the subscript, represents what we call the atomic number. And the letter above, which we are calling the superscript, is representing what we call the mass number. So each word has a definition or definitions which we can use to represent the statement. Number one, if I write atomic number, it means I've counted only protons in the nucleus of an atom. So I'll say atomic number is the sum of protons in the nucleus of any atom. Another person will come to a statement where we said that since an atom is electrically neutral, it means the positively charged protons will be equal to the negatively charged electrons for this to be neutral. So another definition, somebody else will say that this is the sum of electrons on the energy levels, around the nucleus. So energy levels around the nucleus have electrons, and those electrons can also be used to represent the atomic number. Now, if you come to the nucleus and add protons plus neutrons, then you get what we call the mass number. So you will come here and say sum of protons and the neutrons in the nucleus of an atom, simply because both of them are found in the nucleus of an atom. That means that mass number can be equal to protons plus neutrons. And that will be the formula which we are going to use to calculate either the number of protons or the number of neutrons in the nucleus of an atom. If you want to understand chemistry better, this particular topic is very fundamental. And the more you follow the different episodes we are going to make, this is episode 1. The different episodes will have a series of atomic structure, and they will assist you to clearly understand what we mean by atomic structure. Before we leave this section, I'm having sample questions. And question 1 is telling us that the full symbol of atom of element X is X1123. And part A says, state what the numbers 11 and 23 represent. What the numbers 11 and 23 represent. Since 11 is the subscript, it is representing the atomic number, and 23 being the superscript, it will be representing the mass number. That is question 1. Part B says state the number of particles in the atom of element X. Number of particles in the atom of element X. To be in position to answer this, I will begin by naming the particles that I have: protons, I have neutrons, and I have electrons. Those are the particles that the question wants me to identify the numbers for. So if I'm to identify the number, remember this has been particle. This is a particle, and I want the number. We agreed that protons make up what we call the atomic number. And since the atomic number is 11, protons are going to be 11. Since protons are equal to electrons, these are equal to each other in a neutral atom, electrons will also be 11. Now, if I want neutrons, I'll pick this equation. Neutrons will be equal to mass number minus sum of protons, which is 23 minus 11, and neutrons become 12. So I'll come here and say that this is 12. Another question to assist us in understanding the introduction of atomic structure at the part of mass numbers and atomic numbers and the typical structure of an atom. We can be told to the question says state the question says name and state the charge of the fundamental particles of an atom. That is part A, state and state the charge and name the fundamental particles of an atom. So we shall come here and say, if this side I have the name, this side I'm going to be placing the charge in form of a table, such that we can be as brief as possible. The first is protons, and the charge is positive. Some other people will just simply say positive in brackets. The next are electrons, which are negative. The brackets just a minus. The third are neutrons, no charge, or neutral. Part B of the question draw and label the structure of an atom, showing the location of each fundamental particle mentioned in A above. In such a question, our response will be as brief as possible. You come to your answer booklet and come up with a simple and clear drawing that shows the structure of an atom. Since we agreed that the atom should have a nucleus, so draw your nucleus, put protons and neutrons. Even if you draw one single shell and put the electrons there. Since the question said draw and label, we are going to label. This is showing an electron. This is an energy level. This is a nucleus. Capital N is showing neutrons, and capital P is showing protons. So I will be done with answering that particular part of question. The next idea on atomic structure are isotopes. And by definition, these are atoms. Somebody will include different. So these are different atoms of the same element with same atomic number, but different mass number. Alternatively, somebody else will say different atoms of the same element with same number of protons, because protons are the ones making up the atomic number, but different number of neutrons. And from the definition, we can have different questions to clearly show us isotopes. However, before we look at the questions, the behavior of atoms existing with different mass numbers but same atomic number, we refer to it as isotopy. This is existence of different atoms of the same element with same atomic number, but different mass numbers. So you just have to include the word existence to come up with a definition of isotopy, which is not the case on isotopes. Now we can meet different questions. The full symbols of atoms of elements W and X are W 1735 and X 1736 respectively. Part A says state the Roman 1 similarity between W and X, then Roman 2 difference between W and X. When it comes to the similarity, we shall say both have same atomic number. Alternatively, both have same number of protons. This side, we shall, among the differences, have different mass numbers. Alternatively, have different number of neutrons, and we are generating the difference from this section and this section. So make sure that on presentation of work, you present short answers which are correct and precise, such that you don't give hard time to ask the examiners who are going to be looking at your work in order to present correct information. Part B of my question, or the continuation of my question, suggests that I'll put it in blue ink, that name and state the number of particles in atoms W and X. If we are to name the particles, let here be particles. Let here be a number of those particles. I'll present my answers briefly in a table. I have W and X. So particles include protons, neutrons, and lastly, electrons. Protons are represented by atomic number. So both have 17, 17. The same applies to electrons because protons are equal to electrons. Neutrons, you get the mass number, which for W, which is 35, minus the atomic number, which is 17, you get 18, you put it here. For X, you get the mass number, which is 36, minus 17. You come up with 19, which you put here. So you will come up with clear numbers which represent the differences we have written. Neutrons are different. That's why we suggested this answer. Protons are the same. That's why we identified this similarity. So whatever you should write should clearly represent what you have written in the answers. So simply that is atomic structure. We can continue with the question with part C on this side, and we'll look at how we can diagrammatically represent the structure of atom W by use of the numbers discussed below. So part C, draw the structure of atom of element W. I'll begin with the nucleus as an answer. Begin with the nucleus, put protons and neutrons. Protons are 17, neutrons are 18. I think that is very, very clear. I'll draw my first shell or energy level on the nucleus. And we said this one takes up a maximum of 2 electrons. Allow me to represent electrons with a different color other than black. So I'll have my first shell possessing electrons. I'm representing electrons with the, I'm putting a thicker color such that we can clearly see the first shell can only handle 2 electrons. I will put the second shell. So among the 17 electrons, I've so far chopped off 2, so I'm left with 15. The second shell can take up a maximum of 8. So I'll draw those 8. And putting the 8 means I now have 10 from the 17. If I remove 10, I'll be left with only 7 electrons, which will exist in the last shell of the atom of W. So the last shell can have a maximum of 7 electrons. Those are 6 and only 1, which is 7. So if we are told to write the electronic configuration of W, our electronic configuration will be simply the first shell has 2 electrons, the second shell has 8, and the last shell has 7. So that becomes our electronic configuration of W. We shall continue with the episodes of atomic structure, and I encourage you to subscribe to my channel, Smart Science. Like my videos, comment about them in case of any challenge or an encouragement, and share my link with other students out there such that they can easily obtain a clear understanding of this topic, which is called atomic structure. Thank you for watching me. I wish you all the best and continue subscribing to my YouTube channel.